So last day we talked a little bit, Jimmy, about cloning. Dolly the Sheep, I think I gave you the year for that. What year was Dolly the Sheep? 1990, was it 5 or 6, I think? So that was the first large-scale animal to successfully clone. We're getting, I guess, better, if that's the word, at it. So Snuppy was in 2005, roughly 10 years later. But it wasn't an easy process. It was we made 1,095 eggs from donor mothers, and then the DNA from the ear cell of a three-year-old Afghan dog. These eggs were implanted into 123 mothers, only 3 of which became pregnant. 1 of them was a miscarriage. So 2 actually had birth, and of the 2, 1 clone died when only 22 days old. So if you replace dogs with the word humans, and you suddenly, there's some real ethical, moral, ugly issues that come to the forefront. Why would we be interested in cloning dogs? Seriously, why do you think especially rich people would be interested in cloning dogs? Yeah, we want our beloved pet back. Barbara Streisand recently paid a lot of money to have her dogs cloned. But as you saw in the video earlier, a clone doesn't mean identical. It might have a completely different set of behavior, because as it grows and learns and responds, it might develop completely different habits. It might develop completely different personality. There is both a genetic part of you, but there's also the environment that you're raised in, which determines a large bit of how you turn out. Therapeutic cloning. This would be used for healing purposes. This is a very controversial and cutting-edge issue. We have these things that we call stem cells. What are stem cells? You may have heard the term. Stem cells are non-specialized cells that can become specialized. What we mean by that, Marco, is a stem cell can, if necessary, become a brain cell, or become a liver cell, or become a stomach cell, or become a skin cell, or become a whatever type of cell. You all start out as stem cells in your mother's womb, because initially all of the cells that make you up as an embryo are non-specialized cells. In fact, they do one thing: they just reproduce like crazy very fast while you grow. It's only later on that these cells start to specialize and become their specific type of cell. So, embryonic stem, Mr. Dewick, embryonic stem cells are more adaptable and can become any cell type. As adults, as teenagers, you also have stem cells, so we call these adult stem cells. These are less adaptable. And they can only become some cell types. So we're talking about therapeutic cloning here. So therapeutic cloning can use embryonic or adult stem cells. The adult stem cells aren't as controversial. The embryonic ones are, because there is much debate right now as to whether an embryo is already a person or not a person. And I'm not going to get into that debate. It is a long and arduous debate. I'm just going to raise the issues that we have to consider. So stem cells can be used to replace damaged cells. For example, in patients with diabetes, maybe we could replace the cells in your body that produce insulin so that you would no longer have to get insulin shots. Spinal injuries. It would be really neat if we could somehow get spinal cords to regrow for patients that can't walk anymore, that have had a spinal cord injury. These are the three that we're really targeting right now, but even since I created this handout about 5 or 6 years ago, I've read recently, for example, they've injected stem cells into the eyes of people who were blind and had major vision restoration, not to 20/20 perfect vision, but to the point where this person wearing glasses could navigate a room and see obstacles, which is that's a massive game changer. If you can go from I can't see anything to, oh my goodness, I can navigate my way around a little bit, that's a huge life improvement. Ethical issues. Some people feel that it's wrong to destroy cells that are able to develop into an individual, no matter what the purpose, no matter where they come from. So this is, I think, a diagram from your textbook, figure 5.33. What we would love to do would be, for example, let's suppose that Allie has a major health issue. I'll pick on Allie. I don't know your health background. Okay, so let's suppose, for example, that we find out that your pancreas is no longer producing insulin properly and you're at risk for diabetes. It would be really neat if we could harvest cells from your bone marrow that are generic stem cells and somehow genetically tell them, since you can become any cells, would you mind please turning into pancreas cells? And then if we implant them in you through surgery, because they're your own cells, will your body reject the tissue? That's one of the main issues right now with organ donation, is often the organ recipients, their bodies reject the tissue. And you're either going to be on immunosuppressant drugs for the rest of your life, or sometimes that organ, even though we had to wait for somebody to pass away in order to get that heart or to get that lung, it gets rejected, and out of luck, that was just a waste of a transplant. We're still at that stage in our medical understanding. So it would be neat if we can take an adult cell from a patient, maybe combine it with a human cell egg. That's the controversial part. Or maybe we could somehow remove this step. That would make it less controversial. But then you get embryonic cell development, and those cells can turn into kidney cells or insulin cells or spinal cord cells or heart cells, and then you replant the tissue into the original person. And because the DNA from the cell is the original person, in theory, rejection would be far more unlikely. Okay? What's your homework? Pause for a second. I also got some videos, and this thing that says 2 classes from now is not right. Just hang on. So your homework for Monday, but you'll probably get some class time on Monday to work on this. Ready, Cleo? So you can work on the 5.2 homework, but what I've also given you is a Chapter 4 practice quiz and a Chapter 5 practice quiz. You should have 3 handouts. Got all 3? Cleo, you got all 3? Okay, I thought you were like you're saying I'm missing one. Okay, I'd like to mark both of those quizzes in class on Monday. So really, I'd almost rather have you do those 2 before you do section 5.2 homework. Since we're done the chapter, as a study guide, these are some questions, but I'm going to modify this. Bear with me. From your textbook, you can do these on a separate piece of paper, but I don't think I'm going to assign all of them. Hang on here. Page 183. 1, 4, 6 to 8. Yeah, I'm not wild about. Okay, here's what I'm going to say you can try. 1 is good. 4 is good. Not wild about 6. Not wild about 7. Not wild about 8. I don't know why I assigned that last time. 11 is good. 12 is good. 13, definitely. Number 13 says, what are some advantages and disadvantages of asexual reproduction? I think I'm going to ask you that on your test. I gave you some, you should know 2 or 3. And then, page 184, I'm going to shorten this one too. What did I say? Nah, 3 is good. Nah. 7 is good. Nah. Do I have a different assignment for you folks on your sheet, or did I shorten it already on in your notes? My brain is saying I should have done this sooner. I took this from a different teacher, and I just thought there was way too much here. Make a sketch. Nah. 12 is good. To 18? Nah. 16 is good. 17 is good. 18 is good. 20 is good. 21. I'm not going to worry about 23. So you can do that on one page. Now this is due the day of the test. This is partly for your studying. So that's not your homework right now, but if you want to get a head start. On Monday, I also have 2 crossword puzzles because there's going to be a vocabulary section on your test. So I've got a Chapter 4 vocabulary crossword puzzle and a Chapter 5 vocabulary crossword puzzle. That lets you know words that either I'll ask you, there's a matching section, but there is going to be, I think, 5 words where I just say, give me the definition, please. I give you the word and I say, tell me what it means. Okay? Pause this.